Hi folks, in this video we're gonna go through bash logging by process substitution. Well, the logging is it is what it is, right? Logging is saving some form of text onto a file. That's logging, right? Let me just say before we begin, this document requires a good understanding of redirections. So if you don't get what's covered here, I'll link my previous video on redirection on the description. Okay, so if you don't understand this material, go back and watch the redirection video I made first. Okay, so this is the as usual, I made a document about it, and this is sourced from this link. It's a Woolwich website. It's very good. So if you want to learn more, just Google Woolwich. All right. Okay. Regular logging. Common logging use case involves saving both stdout and stderr to file. This may be achieved by this, which is the same as this over here. Again, if you don't understand what's going on, watch the video on redirection first. Okay, let me just right. So let me just all right. So what I mean is, oops, sorry. What this does, it will save stdout and stderr, both of them, to the log file. Okay, and this is same as this. If you don't understand what these redirections do, again, watch my video on redirection first. Okay, and perhaps perhaps we want to save output to file as well as write to terminal. We may use T command for this. Okay, so what T command does, it accepts lines of text from well, it accepts lines of text and then it prints its content to the terminal as well as save it to a file. So if you want to save output to file as well as write to terminal, you can use T command. And it says here, for this end we could do this, which is the same as this. So let me just write it here. Okay, so we could do, what does this do? This redirection is a shorthand. What it does is it will feed in both stdout and stderr of my script, into the T command. Okay, and this is same as this. So what it means is it will, well, normally without this redirection, only the standard out from my script will be fed into the pipe. But because of this redirection over here, both standard out and standard error will be fed into the T command, the right. Okay, so this is just, oops, sorry. This is just a shorthand. Okay. You might want to save standard out and standard error to separate files and print the output to terminal 2. By using process substitution, this can be achieved quite elegantly, as we will see later. So we will visit this later. This next section is simple logging via process substitution. Consider the following. This code over here. Let's discuss this line by line. Okay, so the first line, what it does, it points standard out to a I guess it's a named pipe under the hood. Well, this is a process substitution. Bear in mind that this process substitution initiates a T command in the background, and because of what the redirection we have set here, any subsequent output from standard out is fed into the T command. Let me try to explain better. So we got this, right? I told you that this is something new. This is a process substitution. So, and you know that for example, something like that, this means standard out now points to file, right? But in this case we have this, so you can guess now the standard out now points to this thing over here, right? What is this? I told you this is a process substitution. What you need to take away from this is that from now on, any standard out, well, any output from standard out will be fed into the T command. I'm not sure what's going on here. Why is it? Okay. So just to recap, this redirection over here means standard out now points to the process substitution, and the effect of that is any output from standard out will now be fed into the T command inside the process substitution. Okay. So says this redirection in the first line points standard out to this, we discussed already, which is the process substitution. And these three lines over here, can you guess what effect these will have? You've guessed it. The ones that were the line of command that outputs to stdout in the current configuration, which is, it points to this process substitution over here. Then this output will be fed into the T command, as I have discussed. Okay. But output from echo A followed by this redirection here is not saved to my log. Okay, because the redirection over here resets stdout to point to the terminal again instead of the process substitution. Okay. Likewise, echo B followed by this redirection doesn't get fed into the T command. Okay, so it is not saved to my log. So in summary, among these three lines, only the content of the file called file is fed into the T command, and because of that, the content of the file will be printed to the terminal as well as saved to the mylog file, because that's what T command does. Okay. You may wonder why echo A and echo B, these A and B characters are not saved to mylog, because I've mentioned here briefly, because of this redirection here, the output is not fed into the T command. It goes straight to the terminal. Okay, because well, just do this. What this does, it copies stderr, which is fd2. It copies the pointer in stderr to stdout. Okay. So what it is, this thing over here, it's same as this. Okay, and we are copying the pointer in the right hand side to the left hand side. Okay, and if you think about it, we've only redirected the stdout to point to this process substitution, but stderr still points to the current terminal, right? If you copy the pointer in the stderr to stdout, it in effect resets where the stdout is pointing to. Okay, so for echo A and echo B, their stdout no longer points to this process substitution. It points to the terminal instead. Okay, that's why A and B are just outputted to the terminal, and the cat file output from that is fed into the T command, and therefore saved to my log file, as well as printing to the terminal, because that's what T command what it does. Okay. Okay, so it says likewise echo B followed by this redirection doesn't get fed into tmylog, and its output is not saved to mylog, as we've just discussed. in comparison, output from cat file does get fed into T command. Why? Because of this line over here. So we are redirecting stdout to point to this process substitution. Okay, so anything that gets fed into the stdout in turn is used by the T command as input. Okay, so tmylog command dutifully outputs to both terminal and mylog file. Okay, so the content of file is saved to mylog. Okay, so he says here, remember that T command runs in background. Okay, so the effect of introducing this process substitution is that this T command runs in background. Okay, so if you try to do well, if you try to wait on the end at the end over here, you won't wait for the T command to finish, because the wait command applies to the script, main script, but the T command runs in a separate process. So, so the wait command does not affect the T command. Okay. Yeah, so this causes any stream fed into tmylog command to be processed asynchronously, and this may cause lines of output to be printed out of order. Okay, so if everything was synchronous, then these three lines here, the effect of that, these output will be in order, right? But so it should be A and then followed by content of file and then B. Let's see here. A is alright, but B comes before the content of file, and then high mom is the content of the file, and it bleeds onto the next shell prompt. This is the shell prompt. Okay, I'm sure you've seen this before in other programs. Okay, so it says first notice that the content of file is printed last and bleeds to the next shell prompt. This is the next shell prompt. Okay, this does not adhere to the order the output streams were initiated. We expect B to be printed after file, content of file, but this is not the case. Okay, so this is my guess, but it makes sense if you think that if you notice that the T command will be processed slower than the simple echo command. Okay, that's just my guess. So it says here, tmylog command runs in background and we have no control over it. And here's the wait command mentioned again. If you execute the wait command at the end of the script, it will have no effect, precisely because tmylog command runs in separate process that we have no control over. Okay, so if you execute the wait command at the end, it will just wait for the main the script itself to end, but it has no direct control over the T command, because this process substitution runs in a separate process in background. We will see how we can circumvent that restriction later. Okay, so it says we could add 3 at the end of the script to give some time for the tmalloc process to finish. This will prevent output to bleed onto the next shell prompt. So this will prevent, for example, content of the file to bleed onto the next shell prompt. If you do the same thing at the end, just sleep 3, it will wait until this bottleneck, which is the T command, to finish. So in effect, this bleeding effect will be prevented, okay, because it waits until every process finishes. Okay. Alternatively, we can exercise greater control by implementing this process substitution using what's called named pipe. That's the next section. Okay. By using named pipes, we can exercise greater control over the tmalloc process that we've covered in the last section. So we are in effect re-implementing the process substitution using named pipes. Okay, remember, we were not able to directly control the background process using process substitution because it runs in separate process in background. I hope you understood that. Let's discuss this using an example. Okay, this is using the name pipe to implement what we've seen over here. Okay, we'll go through it line by line. The trap command listens for exit signal and then deletes the temporary name pipe file when the signal is invoked. This is when the script exists. Exit. Okay. So let me. Okay, so what's here? It says pipe file exit. Okay, so what this does is firstly you need to understand what exit signal is. Exit signal is triggered when the script exits. Okay, and when this exit signal is received, it triggers this command. What does this do? It deletes the pipe file and then exits. Okay, so this is like housekeeping. After this has run, you don't need to carry around the temporary pipe file anymore. So when it exits, it deletes the pipe file. So that's easy. nk FIFO command creates a new pipe called pipe $. This $, $, is the process ID of the script itself. So it just gives a unique name. Okay. And then now take a look at the subsequent 2 lines, which are these 2. Okay. stdout now points to the pipe, named pipe, because of this. Okay. tmalloc command receives the pipe, named pipe, as input. That's here. Okay. So the map or the flow is stdout to the pipe, then it gets fed into the T command. Alright. Also notice that this T command over here is forked. It's forked by this. Okay, so I'll show you. So what is a forked process? Forked process is like if you run my script and then you end it with, is it called ampersand sign? You end with this character at the end, it becomes a forked process. Okay. Makes sense, right? You don't want to run this t command synchronously, that is line by line. No, you want it to run in background. That's why you have this. Okay, and I'll just spoil it for you here. This just saves the background process in PID variable. Okay, so this dollar exclamation mark, it is a process ID of this fork process. Okay, why do you need that? Well, you need that so you can wait on it. So it's direct. We are not able to wait on it using process substitution because it runs in background, right? In this case, it is possible because we are immediately capturing its process ID. Okay. But anyway, it says the flow of data is from standard out to the pipe to the T command. So can you guess what effect this will have? Well, what do you think? What these three lines? Will it do something different, or will it have the same effect of the previous example? The answer is it will have the same effect. A and B will not be fed into the T command. Okay, so A and B will not be saved to my log file. Only cat by output, which is the content of bar file, will be saved by the T command for the same reason as what we've gone through before. Okay, it says here A and B are not saved to my log for the same reason we've discussed in the last section. Okay, this dollar exclamation is the PID of process ID of the T fork process. Because we have the exact PID of background process, this time we can wait on it. There is still a desynchronization between stdout and stderr, but it no longer writes to terminal after the script has exited. Okay, what does this mean? Desynchronization between stdout and stderr. Well, it's because stdout points to this name pipe, and the stderr still points to the terminal. So they're separate. They are not linked in any way. So they behave not in a synchronous manner. Okay, especially because this is a forked process. Okay. Do you understand the flow of data here? How the redirections are set up? Let me just go through with you. This line over here, can you guess what it does? This redirects standard out to point to the name pipe. Okay, and this one, it receives the name pipe. Well, let me say it in this way. It redirects standard in to point to the name pipe. Okay, so the flow of data is from standard out to the name pipe to the T command. Okay, so that's why cat bar feeds in the content of file bar into the T command, and the T command in turn writes the content of bar file to the terminal, as well as save it to my log file, because that's what T command does. Okay, it outputs to the terminal and at the same time save to a file. That's why we're using T command, because that's the effect we want in the logging process. Okay, so the effect of this wait command is that we will no longer have a case where output from the script bleeds on to the next shell prompt. Okay, because we wait for the script to end using the wait command. And as I said, in this time the wait command works because we were able to extract the background process PID. Okay. Okay. Okay, so this thing over here, what it does is it closes standard out. Okay. Let me tell you here. This is same as this. And what does this mean? It means close file descriptor n. Okay, so in this case we're closing the standard output. Why? This is a behavior that you just have to know, but when you close a file descriptor, it causes whatever process that uses that file descriptor to terminate. Okay, in this case it's the tmylog command. So closing the file descriptor standard out causes the t command, the t process to terminate. Okay, so without this, the process may not terminate for a long time. For this reason, you close the file descriptor before running the wait command. Okay, just out of convenience. But in a newer version of Bash, it is possible to extract the background process ID of the process substitution for Bash versions 4.4 and higher. Okay, so this is the same thing but without using the name pipes, but instead using the process substitution. Here, first you point standard out to this process substitution. Immediately after that, you can capture its process ID using the same $! And then you do the same thing. You close the standard out file descriptor and then wait on the background IDs after background process process ID. But it does the same thing. In this case, we extracted it from a process substitution instead of forked name pipe. Okay. So here $! is the process ID of the tmyfile command. Well, the t process, and as we've done with name pipe example, we first close the standard out to trigger the process to terminate. Then we wait on that process ID. So it's exactly the same as the name pipe example. So I have made a remark here. So I guess implementing process substitution using name pipes is no longer required for newer Bash versions. Okay, very good. Logging both standard out and standard error together. Synchronize. This is the big word over here. Synchronize. Last time we've discussed how in the past example, standard error and standard out are desynchronized. So we covered that first here. Okay, so we've covered this code in the past section. Okay, in this example, we've mentioned that standard out and standard error are desynchronized, causing output to be out of order. Why? Because standard out points to the T process substitution, and standard error points to the terminal. Okay, so they are desynchronized. And as I mentioned before, this T process is it runs in background. Okay, it says here, if we duplicate one of the file descriptors here, where this is a redirection involving duplication. Here we are duplicating file descriptor 1 to file descriptor 2. What does that mean? As I mentioned before, this copies the pointer in stdout to stderr. So in effect, we're duplicating stdout. Okay. If we do this, everything is synchronized correctly, both on the terminal and in the log file. Okay. So check the output. If you run it, because the command writes to the terminal as well as my log file, first it outputs to the terminal in the correct order, A, hi mom, and B, as well as the my log file's content in the same order. Okay, so we now have seen how duplicating file descriptor means these file descriptors are synchronized. Okay, so this time A and B are also sent to tmylog and saved. Well, that's an important point. Before, A and B were not failed to be fed into the T process, right? That's because of these redirection here. But in our example, it has no hindrance anymore, okay? Because let me go through it. First, we did this, right? This means point stdout to this process substitution. Okay, and what does this do? Okay, duplicate stdout to stderr. The effect of that is now we are copying the pointer in the stdout to stderr. So now stderr also points to this process substitution. Okay, so if you think about it, if you do later, if you do echo A and followed by this, which is same as this, okay, this redirection, does it have any meaning? No, because stdout and stderr, they point to the same process substitution. So duplicating or copying stderr to stdout, it has no effect because they remain the same. Okay, so so for that reason, every line of here are saved to my log and processed by the T command. Okay, I hope you got that. One fallout from this approach is that the separation between stdout and stderr is lost. Okay, that's because of this redirection here. Okay, it copies the pointer to this process substitution onto stderr. So because of this redirection here, you can say that separation between stdout and stderr is lost, and there's still a chance of part of the output coming after the next shell prompt. So like we've seen before, it bleeds on to the next shell prompt. But we can fix it. We can fix this by saving the process ID of the background process, which is this T command, and wait on it. Okay, so what we have, we save the process ID of this T command and saved it onto this variable, and then we do output stuff as usual, and at the end we do the same thing. We close the standard out so that the T command or the T process terminates. Okay, so this triggers the termination, and then we wait on that process ID. We do the same thing, okay, as before. Very good. Logging standard out and standard error. Sorry, logging standard out and standard error to separate files. Okay, so using process substitution, this is easy to do. Have a look at this. Let me just tell you outright what this does, okay? This has the effect of saving A and B characters to mylog standard error file, and the content of bar file gets saved to mylog.standardout file. Okay, so here we are saving standard out to mylog standardout file, and we are saving standard error to mylog.standarderror file. Okay, so let me explain what this code does. Redirections are set up such that standard out now points to this standard out T process, and standard error to the standard error T process. Then these outputs are fed into the corresponding T command. So A and B are saved to the mylog standard error, and the content of bar is saved to mylog.standardout. Okay, I hope maybe you didn't get that. I went that through too quickly. So the redirections are performed left to right. Okay, how many redirections do we have we performed in line 1? 2, right? This one and this one. So let me go through it one by one. Okay, this has the effect of point standard out to the first process substitution. Okay, the second redirection is this. Okay, this points standard error to the second process substitution. Yep, so you need to understand what these do, right? So, and then we do echo A this. This is same as this, as we've seen before. And what does it do? Duplicate pointer in standard error to standard out. So what does this do? Remember, standard error points to the second process substitution. Okay, so it has an effect of standard out now pointing to this second, to this, right? So because in echo A and echo B, now we got the standard out pointing to the second process substitution, A and B are saved to the mylog standard error file. Okay, so what about cat bar? Because of the line 1, we have standard out pointing to the first process substitution. So cat bar has an effect of saving, it has of feeding in the content of bar file into the first process substitution. Okay, so in effect, let me recap. Characters A and B are fed into this T process. Okay, the content of the bar file are fed into this T process. Okay, here one important thing that I don't really get at the moment. You see this redirection over here? If you omit this, script no longer works as expected. I've tried hard to understand the role of this redirection here, but so far I've been unfruitful. The audience, if you're watching this and you know why, you know the role of this redirection, please tell me in the description, tell me in the comment section. Thank you. Alright, the last section now. Logging standard out and standard error to the same file. Okay, so in the past section we went through how to log to the same file by duplicating the file descriptor. Yes, here the duplicating done here. So let me recap. This first line has an effect of setting up the redirection such that both standard out and standard error points to this process substitution. Okay, so you remember what will be the effect of that redirection? We've mentioned that because of the line 1, both standard out and standard error points to this process substitution, right? So the effect is all of these will be fed into the T process. Okay. We noted that one downfall from this approach is the separation between standard out and standard error is lost. Okay. Now we introduce a way to do the same without causing this separation by using process substitution. This is what it is. It looks very similar to this, but the only difference is both T process outputs to the same file. Okay. So notice the A flag of the T command. It means append to my log file. Okay. You can see at the very first what does this do? It touches or creates my log file empty. Okay, and then we append to the same file. This A flag is absolutely needed. Yep. Okay, this appends to my log without truncating it. Okay, this flag is required for these redirections to work. We could also wait for the T process to finish for the same reason as above, to prevent output from bleeding onto the next shell prompt. So this is what we can do. So we separate the redirections to two parts. This one is the first redirection, that's the second redirection, and for each, immediately after each, we save their process ID. Okay, and then we send stuff, and then we close so we close both stdout and stderr so that these T process are triggered to terminate, and then we wait on both process IDs. So okay, before we finish, let me remind you what redirections are in play here. Yeah, let me write it here. Okay. So I'll just say first T. Okay, so what does this do? It points stdout to first T process, which is this over here. I'll call this one first T process. This is the second T process, okay? And then the second redirection, can you guess? It points stderr to second T process. Okay? Well, it says the separation between stdout and stderr is not lost in this last example. I'm just thinking, how is it so? Oh yeah, because they point to different process. Okay. So what does this do? This is same as this, as we've said, and this duplicates pointer in stderr to stdout, right? And we've seen here the stderr points to the second T process. Okay, same thing. Echo B duplicates pointer in stderr to stdout. So what does that mean? Now the stdout has the same pointer as stderr, and stderr points to the second T process. So can you see why? So A and B are fed into the second T process, and it saves it to my log. Okay, and cat file stdout points to, can you guess? First T process, right? So the effect of cat file is that content of the file name, which is I think hi mom or something, that gets fed into the first T process, but they both save to the same file. Okay, but we've achieved this without causing stdout and stderr to point to the same destination, because we created a new process using process substitution. So the separation between stdout and stderr is not lost. And here we're just preventing the script to bleed onto the next shell prompt by waiting on the T processes. Okay, and just to finish, let me remind you that we have achieved this by extracting the process ID of each process substitution. Okay, thank you so much for persevering with me. I will link this document to the video description as usual. That is what I do. So you can watch this video again and follow along. Thank you so much. See you next time. Bye bye.